All right, welcome back to Binary Adventure Rust tutorial. So today I am going to cover in depth Rust mutability, moving and borrowing. And the purpose of this video is to make your life easier if you're struggling with these subjects in Rust, if you find yourself fighting with the compiler, not understanding, feeling overwhelmed, questioning why you might have even trying to learn Rust, and etc. Because it is very difficult, especially if you're coming from C or C++, because you're going to try to do things that you were able to do in C and C++, and the Rust compiler will continuously yell at you, okay? And so what I did is I actually wrote an article about this, which you could see at this link here in the Rust forum. And I was going to just sort of freehand this video tutorial and just be kind of typing and coding and showing you stuff. But I felt that if I did that, it might get messy, hard to follow, and ultimately, I want to give you, as the viewer, the most bang for your buck and just kind of address all of this stuff in a systematic and structured way. So I decided what I'm going to do is follow this like presentation style and just go down my own article and explain it for those of you who would prefer to watch a video than to read an article, okay? And then I'm probably going to talk about like one extra subject that I didn't put in the article. And so another thing I'm probably going to do is index the video so that you can go down to the video description and you can click different error types and it will take you directly to how to solve that problem in the video. And this is something I haven't really seen done before in a programming language tutorial. Most programming language tutorials just cover all the basics that are covered in a book. Instead, I want to cover all the hard parts and the parts that you're likely to struggle with if you're already a programmer and you're going into Rust. And I think that this is an important distinction, and I'm hoping it can serve as a reference, almost like Stack Overflow. And one more point I want to bring up before I start actually going into the lessons here is that I want you to either speed the video up using the YouTube controls or slow it down if you feel that it's either too slow or too fast, because you can make usage of those things. Okay, so without further ado, first subject we're going to talk about is mutability. So take a look at this code right here. So you have your main function. Everybody knows what main functions are. And then we have a let statement, let name equals Thomas. And then we try to reassign name to Jane. Okay, and then we try to print out name. Now, this code's not going to compile in Rust. You're going to get this error. Cannot assign twice to immutable variable name. Why is that? Because we said let name. In Rust, if you just use a let like this without any other keywords, it's going to be immutable by default. Immutable meaning not changeable from the initial value. So that means that Thomas is all you can assign a name, and you can't come down here and try to reassign anything. Okay? So in order to fix this, we have to change one thing. We have to add the keyword mute here. So you say let mute name equals Thomas. And then you change the name to Jane, and this code builds and compiles just fine. Now, I want you to note that here I am using basically static strings to demonstrate this. But this is true for all variable types in Rust. So if you're dealing with an integer, if you're dealing with an unsigned or a float or whatever, you have to put mute if you want to change anything, including structs and complex types as well. Okay. Now I'm going to talk about references. So in Rust, references are a type of a pointer. For some reason, they don't seem like they like to use the word pointer that much in the Rust docs. They would prefer to use the word references because that's what they call the construct officially. But make no mistake, these are a type of pointer. And if you're coming from C, C++, or assembly language, you're going to know these as being pointers. Okay. So let's look at this code here. Let mute name equals Thomas, name equals Jane, and then now we're going to create a reference to the variable name, okay? And we're creating an immutable reference here because, again, we don't have the mute keyword, okay? And all we're trying to do is print it out. Now, this, you would think this would be okay, right? Well, first of all, it's important for you to know that we're actually using an immutable reference to mutable data. So this can be a little bit confusing because the reference type itself can either be mutable or immutable in and of itself. And then that's separate from the variable type that the reference is pointing to. Okay? So what this means is that you can have an immutable reference to mutable data, or you could have an immutable reference to immutable data. But you can't have a mutable reference to immutable data. That's just something you have to know, because what you're saying when you create immutable references is that the data that the reference is pointing to can be mutated via this pointer, okay, or this reference. Now, that's not the case if the data is created as immutable, and so that's why you can't do that, and that's kind of what I explained down here. Now, let's look at this code example down here. We have let name equals Thomas, and then let name ref equals mutable reference to name. Then you're going to get this error: cannot borrow immutable local variable name as mutable. That illustrates the point I just made. You can't assign a mutable reference to immutable data. Okay? And I already explained why not. So this is a struct type in Rust. Pretty basic looking thing here. We have a string, we have a unsigned 8-bit integer, and then we have another string called description. So we have name, age, and description, simulating a player. And then this is how we're going to actually new that up, just FYI. So we're going to create a mutable variable called ourPlayer, which is going to hold a player, and we're going to initialize all of these fields here to these values. So now we're going to talk about what a move is, because you're going to hear about this a lot from the compiler. In Rust, a move means that data's ownership has been handed over from one function or method to another. It's very similar to automobile ownership. With cars, the owner holds the car and the title. Once he transfers the car and title to someone else, he no longer owns the car and he does not have access or control over it. So let's look at this code down here. Okay. So we have our struct player. We new the struct up, or we make an instance of the struct here. Okay. And now what we do is we have a function down here that we've defined called mover. And what I want you to know about this function is that the way we've defined it here, it is going to move whatever player is passed into it into itself. So when we call mover and we put our player in there like this, the way we've done it, we're actually transferring ownership of the ourPlayer variable into the mover function, meaning that once we've run this mover function, our main function, which is making the call, can no longer access, read, write to, or use ourPlayer anymore. So when we try to do that down here, that's going to generate a compiler error. Okay? And that compiler error is this one right here. Use of moved value ourPlayer.name. So this is like a trip to a lot of programmers who start with Rust, because typically in many other languages, if not all other languages, when you do something like this, what's going to happen is you're passing it by value, it's called. But that doesn't mean that you can't use it anymore. You would just basically pass a copy of the ourPlayer into the mover function, and then you could still pass more copies and do other stuff with ourPlayer down here. You can't do that in Rust when you do a move. Okay? So now we're going to make a change here. We're going to change a few things. So instead of having the mover function where we pass ourPlayer in it directly, we're going to pass a reference, an immutable reference of our player into this function called Immutable Borrow. So what we did is we renamed mover to Immutable Borrow just for the sake of sanity, so that I'm not saying that something's being moved when it's not. And now we're passing an immutable reference, or we're performing an immutable borrow on our player. Okay? And you can note that by the ampersand there. So note that you have to actually pass with the ampersand in the function call, and down in the function signature where you're defining the function, you have to also place an ampersand in front of the type. Okay? And notice I also changed it from moved to borrowed, because that's what we're doing. Now, this code compiles just fine because we're borrowing our player in this function. We're no longer moving it into the function. Okay? Now, there's limitations on what Immutable Borrow can do in this situation. Okay? Immutable Borrow cannot modify our player in any way. It can't change the name. It can't change the age. It can't run it through some other function that modifies it. It can't do any of that, because the only control we've given it is read access, because we've passed the immutable reference into the function. Okay? Now, this is what's crazy about Rust. This is one of the things that is just like a gotcha, and it drove me nuts at first. It will drive you insane. Okay? So check out this code here after I just described what I did. So here we create an unsigned 8-bit integer. We assign the number 55 to it. It's called age. We pass it into our mover function again, which should, we should be moving age into mover, right? Because we're not passing it by immutable reference. We're just passing the actual variable in there. So we're doing a move here, right? Well, it turns out that this code compiles just fine. Even so, in other words, we've supposedly moved age into the mover function, and then we tried to use age again. Now, up there, when we try to do that with our player, it wouldn't build. And I showed you the error earlier. Why it wouldn't build. It said use of moved value rPlayer.name. Now, this one builds just fine, and I'll prove it to you. I'll run it right now. See? This one runs just fine. Why? So the reason why that is able to sorry, I had to get back to my spot. Next time I want to open up a new tab. But anyway, so the reason why that works is because Rust is doing something behind the scenes here, and it's not showing it to you. It's not immediately visible in this code. Okay? And what that is there is a trait. And you can read about traits. I'll put the link in the description. But just a real quick overview of what a trait is it's very similar to an interface in C# or Java. Basically what it does is it allows you to create an abstract type that you can program against. So you could say, I only want to accept objects into this function which implement a specific type of functionality. So I only want to allow objects into my function or data into my function which implement the display trait, meaning that they can be written into standard out. Okay? So that's what a trait is. If you need to learn more about traits, I suggest clicking the link I'm going to put in the description, and it'll explain it to you. It's not very complicated. It's not as complicated as an interface because traits only deal with functionality and not fields or anything else in the struct. Okay. So there's a trait called copy with a capital C, and it turns out that all primitive types in Rust, such as 32-bit integers, 8-bit unsigned integers, 64-bit integers, and unsigned integers, and various other types, they implement this copy trait by default. And what Rust compiler does is if a data type implements the copy trait and you try to do a move, it's not going to move it. Instead, it's going to copy it. It's going to copy the data in. So it's essentially doing a pass by value like you would do in another programming language. But it doesn't really tell you that. So that's the reason why this code compiles, because U8 implements the copy trait. Now, up here, our player, or our player struct here, it doesn't implement the copy trait. We didn't implement the copy trait for player. Okay. Also, I want to point out that the string type, also does not implement the copy trait. So if we were to just take a string and try to move it into a function, then it would move. It wouldn't be copied. So moral of the story is, before you start pulling your hair out about why a certain type gets moved immediately and then another type doesn't get moved, check to see if the type implements the copy trait or not. That's a big, huge gotcha. So another point I want to make is that there is no mutable or immutable moves. So when something gets moved in Rust, a whole ownership of the item is transferred over to whomever it's moved to, meaning that the original owner can no longer access or modify it at all, like I was saying, and the new owner can do whatever they want with it. And in fact, by default, if the new owner goes out of scope and doesn't pass the moved data back, doesn't move it somewhere else, then it's just going to get destroyed, and you won't have access to it anymore. Okay. Now, we kind of mentioned this earlier, and I showed you an Immutable Borrow, but let's actually talk about what a borrow is. Okay. So again, an Immutable Borrow looks like this. We use a single ampersand before the data when we pass it in to a function. And this is also true with a regular assignment as well. So in other words, if we have something like this. So if we have let name equals Charles, and then we say let p name, I'll put like, if we have let p name equals ampersand name, this is also an immutable borrow that we've created. And what I want you to know about a borrow like this is that this borrow exists until the code execution reaches this bracket or this curly brace here. Okay. So what that means is that we can't do this now. We can't say let m name equals and mute name. Even if this was mutable. Check this out. Cannot borrow name as mutable because it is also borrowed as immutable. So what that means is that when we reach line 6 here of execution, name is still borrowed by this pname variable, and that doesn't end until here. Now check this out, okay? Pay close attention here, because this is a very subtle thing. I'm going to place curly braces around let pname equals immutable reference to name. Now I'm going to run this code again. Code builds just fine. Why is that? Because remember what I said, when execution hits the next closing curly brace after the borrow is done. So pname has returned the item that is borrowed now back to main. So that means, again, just to illustrate the point even further, if we put another curly brace here, like this, let me ask you this question. Where does the borrow end? Where does the pname equals immutable reference to name, where does that borrow end? It ends here. It doesn't end here, and it doesn't end here. Now, where does this borrow end? It ends here. Very important. Now, I don't want to confuse you with the borrow and the reference thing. So I'm going to tell you right now that coming from C or C++, you're going to want to call these references. You're going to want to say, ampersand name is a reference, and you're going to want to say that name is a regular variable. Okay, and then you're going to want to say ampersand mute name is a mutable reference. This is true, but in Rust, it's much easier to think about this as this is a borrow. Anytime you see an ampersand, something's being borrowed. That's a borrow. So instead of thinking pass by reference, think pass by borrow. And when you don't see an ampersand, like if we just pass the name like this without an ampersand into a function, think pass by move or moving something. Okay? That's very important. Very, very, very important to remember, because that will help you solve these issues. Because when you see compiler errors, they're almost always going to be talking about moves and borrows. So if you're thinking about things in terms of references and immutable references, it's like more lingo for your brain to try to juggle around, and it's just harder to understand that way. So that's just like a little tip that I had that really helped me out. Okay. Now let's go over immutable borrow. So the thing about immutable borrows is you can have as many of them as you want if that's all you have. So let's go ahead and get rid of this. I'm going to illustrate this to you here. It's kind of funny. I was planning on just going down the article, but I think it might be better to just do some actual illustration here, right? So check this out. So now we just have two different immutable borrows on name. This is fine. This code will build. Okay. In fact, we could do more. We could say, let's do another one. Let another one equals name. Now, the reason why this is fine, I'll run it again. You'll see. You can have 200 of them if you want. The reason why this is fine is because none of these references allow anybody to change name. The only time that name can be changed is by using name itself. Okay. But see this right here? Cannot assign to name because it is borrowed. Again, so what we're trying to do here is we're trying to mutate data that has been borrowed by other items or other objects. And you can't do that in Rust. This is how it enforces the safety, the memory safety I was talking about. Because the problems occur when somebody changes data that someone else doesn't expect, and then or somebody destroys data that somebody else doesn't expect, and then the other person, person B, tries to access the data that's been changed unexpectedly or destroyed. Okay? And the way that Rust prevents this is by enforcing these borrows. Now again, if I go like this, indentation is pretty ugly here. But if I go like this now, all of these borrows are going to be returned by the time we change Johnny. And so now it builds again. So the other thing is we're going to cover mutable references now, because you can have as many immutable references to a variable as you want. But there is quite a bit more restriction on mutable references, as you might assume, since mutable references allow you to actually write and change data. Okay? So what we're going to do is clear all this out. Let mute name equals Charles is what we're going to have here. And now what we're going to do is we're going to create an immutable reference. So we're going to say let mute ref equals mute name. And I want to point out another interesting thing here, okay? So you can have a mutable reference, or you can have an immutable mutable reference. So check this out. Okay, these are both allowed, not at the same time, but these are both valid lines here. So you might be wondering, what the heck is the difference between these two? So here, the reference type, the reference variable itself can be changed. So if we have this, what we can now do is this. So what we're doing here is we're mutating the reference itself, not the data, but the reference itself. And I meant to do that. So we're mutating the reference. So let's just see if that builds. I'll comment this line out. Okay. That builds just fine. So what we did is we made a reference, and first we assigned it to point to mutably borrow name. Okay. Then we said, you know what? Let's change mutable reference to mutably borrow name 2 instead. That's okay because we have this here. Now, if we got rid of this, watch what happens. Can't do that. Cannot assign twice to a mutable variable mute ref. So when we define something as being mutable over on this side of the mutable reference definition, we're talking about whether or not the mutable reference itself can borrow different variables at any given time. So at first it's going to borrow one variable, then it's going to borrow another variable, etc. So if we get rid of that mute right there, then it can only borrow from one variable, and that's the variable that it's originally defined to borrow. That makes sense? Now, on the right-hand side here, this is talking about whether or not the reference can modify the variable that it borrowed. So if we have this, we now have a immutable reference, which is mutable, meaning that we could do this. We could say mute ref equals ampersand name 2. That's totally legal to do that. Okay. Comment that out, run it, show you. Totally legal to do that. Okay. However, what we can't do is we can't change name 2 using this reference. So we can't do this. We can't say mute ref equals, or dereference mute ref equals Carly. We can't do this. Watch this. Cannot assign an immutable borrow content. So the thing is that we have borrowed name 2 immutably. So we can't use mute ref to change it. So that's why that's not legal. So I hope this is starting to sort of make sense. So if there's mutable on the left-hand side, then we're talking about whether or not we can reassign the variable on the left-hand side of the equal sign. If we have mutable on the right-hand side, then we're talking about whether or not we can modify the data that the variable on the left-hand side has borrowed. Okay? All right. So now I'm going to go back to the article. So yeah, so that's what Immutable Borrow is it allows you to change the data. Now, let's talk about some of those restrictions. First of all, you'll note that whenever you make a call to a function and you're passing in, or even if you make an assignment and you're doing Immutable Borrow, you have to put the ampersand mute there. So the ampersand mute actually has to be placed in the call and in the function definition. If you leave one out, that's going to be an issue. Specifically, if you leave it out of the function definition, it will be an issue. And in some cases, if you leave it out of the function call, it will be an issue. So, for example, if you were to pass an immutable reference into a function that accepts a mutable reference and then tries to change it, that's going to create a compiler error. But if you were to pass a mutable reference into a function that takes an immutable reference, that's not going to cause a compiler error because the permission level in which you're giving the function at that time is less. So meaning if you're giving it permission to mutate the object, it's implied that it can also read the object, and so therefore the compiler is okay with that. But on the other hand, if you're giving it an immutable object or borrow, then and then you're trying to actually mutate that data in the function, then the compiler won't let you do that. So it's very important to understand those things there. And another thing is, when you have a mutable reference out, you cannot have any other references. So when you have an immutable borrow, or when you have a mutable borrow, excuse me, you can't have any other borrows in place in that scope. So again, let's just demonstrate this. So we're starting out with these two mutable variables here, Charles and Johnny, name and name 2. So let's make a mutable borrow of name by doing this. We'll say let m be, and we don't need to make the actual reference mutable, but let's just say we do this. We'll say let m be equal mutable borrow of name. Okay. Now this is totally fine. This will compile as is. It will run just fine. Now, let's try this. Let's say let mb2 equals mutable reference to name. See what happens. Can't do it. Cannot borrow name as mutable more than once at a time. All right, well, maybe it'll let us do an immutable borrow. You know, maybe it just doesn't like having two mutable borrows. Nope, can't do it. Cannot borrow name as immutable because it is also borrowed as mutable. So again, Rust is not going to let you read from data when it's already being borrowed mutably. Now again, if we were to change this to an immutable borrow like that, this is fine. Bill's just fine. Okay. So let's change that back to immutable borrow again. And now I'm going to try something else that's a little bit clever here. What if I try to mutably borrow the mutable borrow? So let's say I say let mb equals and mute mb. So see what I'm doing here is it's sort of like in C if you made a pointer to a pointer. I'm trying to mutably borrow MB, which is mutably borrowing name. So I could double dereference here and then change name. Well, as you might imagine, it's not going to allow that. Cannot borrow mutable local variable MB as mutable. And, oh, by the way, so that's because I left this out, but it's still not going to work. So even if I were to make this mutable like this, it's still not going to work. All right, let's see. Actually, that did work. So my bad, because here we're just changing the pointer. All right, so I'm going to move on to, what else do I have here? So you can see here that change name is being used to actually do Immutable Borrow and do something useful with it. So we pass in Mutable Borrow of player, and in this case we pass a Mutable Borrow of our player into ChangeName, and then ChangeName would actually act on the data, and then it will be printed out and reflected. So check this out. So we can see here, I am Jones, I've been immutably borrowed. My name is my new name, and I am being used after Immutable Borrow. So here we immutably borrowed our player, but we returned it. Then we took out a Mutable Borrow of our player, and then we actually acted on it, and then we printed it. Now this is fine. And the reason why this is fine is because our Immutable Borrow was actually returned, because this is another sort of subtle, confusing thing. Unless you capture something here, so unless I do this, now if I do this, there's going to be an issue, because now remember that this borrow is going to last until this closing curly brace. But before, without this here, the borrow actually returns at the end of Immutable Borrow function. So, oh, I know. I need to fix this real quick too. I need to actually return. I need to return borrowed. So in Rust, this is the same thing as typing return borrowed. But you don't have to do that in Rust. You can just type in what you want to return. No semicolon. So C cannot borrow our player as mutable because it's also borrowed as immutable. So same error as earlier, but a little bit of a different context here. So, but then if we were to go and remove this again, and then run it, we're good again. So. Okay, so let me go back. I clicked off of it again. So we covered borrows pretty thoroughly. So they end at the last curly brace as shown. So let's go over a summary here. So one critical error that many new Rust programmers can make coming from languages like C and C++ is that when we see ampersand, we think pass by reference, and when we see no ampersand, we think pass by value. So I talked about this earlier. It's easier to think of that as pass by borrow in the case of an ampersand, and pass by move in the case of no ampersand. So as I said in my article, please go in the Rust playground and experiment with all this stuff. Play around with, data like I was doing here. See what causes errors. See what clears those errors up. Try to do things several times in a row, and you will be able to sort of learn and experiment for yourself and get a hang of this stuff. It's not that hard. So there's a couple other things I wanted to go over in the video here that will really, really save you a lot of time. And one of those things is how Rust handles self. So check out this code right here. So we have our player, and then we define a method called printMe on player. So this is the same thing as just defining sort of like a class method, but this isn't a class, but it's close. It's similar. So when we say implement player, it just means define methods on player. So printMe is going to be a method where you could say like rPlayer.printMe. And then as you usually see in Python, we pass self. This is seen in many other languages. We pass self in there, so that way it gives us access to the data on the object, right? So we can do self.name, self.age, self.description. Now, when we run this code here, we new up a player, and then we run the printMe method. This is all good, right? It works just fine. Now, if we do this, The only thing that's changed here is we're calling ourPlayer.printMe a second time. So all this code's the same as the above code, except we just literally added one more line, ourPlayer.printMe again. Okay? Now this won't compile, and I'll show it to you right now, and I'm going to remember this time to open a new tab. This code will not compile, and at first this will drive you nuts. It says use of mood value ourPlayer. So it's like, what the hell is going on here? This doesn't even make sense, because at this point we're using an object, we're trying to run some methods on the object, and you can't run it more than once. That's very strange, right? So it turns out that the reason why that won't compile is because if you look at the code here, it's because of this right here. When we defined our method, we said that it takes self, that it moves self. Okay? Remember, in other words, we didn't use a borrow here. We didn't put ampersand. So what's going on is when we run printme on line 25 the first time, it's taking ownership of the parent object. So our player is being placed into, it's being moved into printme. And then what happens is that once this curly brace is hit, we just destroy the object. And so by the time we get to line 26, there's no more our player. It doesn't exist anymore. It's not accessible. Because we moved it into printme on line 25, and then we destroyed it because we never passed it back out. And that's what causes this error here. So there's a real simple fix for this, and all you do is you put an ampersand there. And now we've made an immutable reference to self rather than self. And so when printme runs, it now just, it borrows self and then it returns it when it's done. And then it allows us to run our player printme more times. So I'm going to run it now. See, now it works just fine. We can run it 5 times if we want to do. Doesn't matter. We can run it as many times as we want. Okay. Now, just to illustrate a point, because it's, and this is really weird, I wouldn't program like this, but just to illustrate a point, I'm going to change this slightly, and I'm going to put it back to regular self. I'm going to make printme return a player type. I'm going to modify the method to return self when it's done with it, and then I'm going to say let temp equals ourPlayer.printme. So what's going to happen here now is we're going to move the struct object into printme. We're going to act upon it, and then we're going to pass it back out. We're going to move it. We're going to move it back out, and we're going to move it into the temporary variable. And then finally, what we're going to do is we're going to run temp.printme again. Okay. Now this will work. This will run twice. So that illustrates the point I was trying to make, which is that printme took ownership. The self was moved into printme. It took ownership of self, but then it gave up ownership down here, and ownership was then transferred to temp. Then we ran temp.printme and we moved ownership back in. Now, if we don't take ownership back and we try to run temp.printme again, watch this. It's not going to build. Use of move value temp, because temp was moved. It was used up, okay? So that is like a crazy little gotcha that really threw me for a loop for a while. And I would imagine it would do the same for other people. Now, I want to cover 2 more things really quick, because one of them I didn't cover in my tutorial, my article there. And so I'm just going to use a Stack Overflow example here. And that is another one you're going to see a lot, which is cannot move out of borrowed content. And it's like, what the heck does that mean? It's kind of a hard one to understand. And it's a very similar concept as to what happened, what I just showed you, okay? So what this guy is trying to do is he's saying for line in self.something, self.bufferClear, and then for current char in line.inDevice.iter, self.buffer. He's basically using self a lot. The problem is he's not using a mutable reference to self or an immutable reference to self at all. He's just using self. So what happens is that self gets moved and used up when this loop gets iterated through the first time, and then because basically what it's getting borrowed, and then he can't do a move. That's what he's trying to do. So the answer that was written explains it really well. It says this takes self, not a reference to self. That means that self will be consumed and won't be available after the call. In its place, you get a vector U8, and the prefix into is a common way of denoting methods like this. And so, again, he's using self instead of borrowed self, an immutable borrow self. And if he needs to actually modify self, he may even need to use a mutable self. Like, for example, in this function here, a mutable self is actually passed. So just to actually illustrate that a little bit better, we could define another method called ChangeMe. Okay, and ChangeMe is going to change the name to something else. So right now the name is Jones, right? So we're going to change it to some other name in this function or in this method. So we're going to say self dot name equals some other name dot toString. And toString is just converting a static string reference to a proper heap string here. Okay. Now I'm going to get rid of this, and then in between here I'm going to write or actually I'll get rid of this too, because we're going to have the same issue we had before if I don't. So I'm going to say temp dot, actually I'll put it up here. Our player dot ChangeMe. Okay. So see now we had Jones in here, and then we immediately changed it to some other name, and then we printed it out using that printme. Okay. And notice that was all fine. It ran just fine because we had to pass a mutable borrow. We had to pass by mutable borrow here, because if we would have done this, not going to work. It cannot assign to field of self.name of immutable binding. So the reason why we were able to get away with this up in printme earlier, the reason why we were able to get away with this is because printme is only printing, it's only reading. It wasn't trying to change anything. But if you have a method that needs to change self, then you're going to have to use a mutable borrow to self. Okay. So that pretty much covers everything I wanted to cover, except one last little hint here. And that is, you're going to see people on the forums and all over the place talking like this. They're going to be like, is player display, is U32 copy? My cool type is display, it's copy, and it's clone. What this means is, does the player type implement the display trait? Does the U32 type implement the copy trait? And my cool type implements the display, copy, and clone traits. So they're just talking about implementing traits for different types, but they use shorthand, which just is like, is player display? Is it send? That just means does it implement the display and send traits? So that's it for the tutorial here. I hope this has really helped you understand, some of the oddities of Rust and the complexities of this, the borrow system and the move semantics, it's called. I think that going through that in an error-based way is beneficial, not just for immediate learning, but also to teach you how to learn from the compiler errors, so that way you don't have to keep asking questions. You can start to, because the errors are actually not too bad. Some of them could be better. Like, I don't really like the one about cannot move out of borrowed content, but the rest of the errors that I've encountered, a lot of them are actually pretty useful. Okay. So I hope that helped. And if you guys have any questions, if you guys or gals have any questions, feel free to drop them in the comments or get on the Rust language forums at users.rustlang.org. And I hope everyone has a great day. Thank you for watching. Bye.